Hello, I'm Antigone Chrysostomou, and I'm leading the Azure HPC business in EMEA at Microsoft. This session has three parts. I will speak to you about how we are becoming more and more the trusted advisors of our customers for digital transformation, with HPC being a strong driver of business value creation. Alexandre Jean will share with you the concrete steps we take to support our customers on board on Azure. Gabriel Salla will zoom into digital engineering transformation using Azure HPC. This scenario is integrating end-to-end design, manufacturing, test, and simulation of products. Let us look at the challenges most organizations are facing today. They have to deal with a globally distributed workforce, and after COVID, more and more with hybrid work models in almost all countries they operate. They need to constantly increase innovation, secure their competitiveness, reduce time to market, and finally care about sustainability. Transforming IT and modernizing customer experience are now part of the strategy. At the same time, they have to maintain security of their company data, achieve operational efficiencies, reduce cost, and minimize risk. Most of these challenges hold true for both for industries as well as for public research institutions. With data being the key asset at the heart of all business processes, the need for more complex calculations is increasing in all sectors. Extending the on-prem HPC environments with cloud resources unlocks significant new capabilities for all industries. As we're looking at transforming the workflows of our customers, we are addressing a variety of industry-specific use cases requiring HPC calculations. The main areas we're engaging with are the public sector and scientific research institutions, life sciences, energy, financial services, automotive and mobility, as well as manufacturing. Now, how do we measure the value? The power of transformation with doing HPC in the cloud goes beyond the idea of lifting and shifting usage of IT hardware components from a local data center to virtual machines. Microsoft has built HPC specialized infrastructure in Azure, yes. However, comparing on-prem core hours and the associated cost with the Azure VM cost models does not take into account the full value you can get from Azure. The real value is created when looking at the workflow or use case end-to-end and consider multiple optimizations we can achieve, be it reduction of total simulation time, license cost optimization, inclusion of AI into the use case, and much more. Besides, the cloud pricing models do include a full TCO calculation of data center operations. They're looking at the total cost of ownership. So we rather need to ask the question about the performance I get for the dollar or any other currency or budget I'm spending. This is why we need to move away from purchasing patterns based only on the core hour price, but find ways to consider the added value of the cloud in future buying decisions. Now, we also got some real customer success stories to share. In the public and research area, a university creates their own HPC lab on Azure as a one-stop shop for researchers, for them to have access to the most recent technology. Another very prominent example, a large meteorological service entity decides to go for a full transition to Azure. Life sciences, a pharma company achieves acceleration of drug design. And another one with hundreds of life science laboratories is benefiting from introducing automation into genome sequencing. In the energy sector, a renewables company we work with achieves efficient energy production and cost savings through wind farm optimization. An oil and gas company can run rock analysis in days instead of months. In the financial services sector, multiple banks achieve already significant cost savings in the range or above 25% by running their risk grade calculations on Azure. Another bank, which happens to be in Germany, moves complex derivative calculations to Azure and saves more than 1 million per year. If we look at automotive and mobility, we have repeatedly proven that we can reduce the total time of simulations, as an example, crash simulations, and also achieve license cost optimization. Multiple companies run their autonomous driving assistance systems, the ADAS use case, on Azure, leveraging also artificial intelligence and Internet of Things scenarios. In the manufacturing area, there is a German company using burst scenarios into Azure to reduce significantly their R&D project cycles. Another global manufacturer improves their employee experience and time to market, having the engineering workstations on Azure and getting at the same time faster simulation results. Now, if Azure HPC is the treasure island, where is the map? On a more serious note, we do have a strong team of HPC experts, and we are working hand in hand with our customers to guide them through the transition, to help them onboard, to teach them how to navigate. If you decide to onboard on Azure, we will support you mitigating your risks and securing your assets. Now, Alexandre Jean will speak to you on how we are preparing our customers for that journey. Thanks for listening.
Thanks a lot, Antigone. Good morning, good evening, everyone. My name is Alexandre Jean, based in Paris, and I am an HPC specialist at Microsoft. And I will cover today the following subject: a journey to the cloud, how you can test HPC on Azure. Just to clarify at the beginning of this session, I won't present any technical stuff. It will be more an approach on how we can collaborate together. If this question is not clear for you, let me rephrase it. Compared to on-premises solution with Azure, you have the opportunity to test your application or workflow on Azure with no risk, and in minutes, you can have a full HPC environment running. So let me ask you again the question: how do you imagine your journey with us and your application? Regarding HPC application on Azure, for your user or end user or engineer, the interface will be more or less the same. Why? It's because we do support all the available schedulers. For example, it can be Slurm, LSF, and it can be many other schedulers. It can be as well submission portal. It can be your own application as well. Because we do provide Linux or standard Windows. We don't have specific solution. But the infrastructure underneath can be really different. This is why Microsoft proposes a framework to bring you a step-by-step into Azure. Let's go back to the slide now. This picture is not a sunset, but definitely a sunrise. Indeed, a sunrise to express the beginning of your journey with Microsoft. So let's say you start talking to us and you want to understand how Microsoft can help you with your HPC simulation challenges. We have challenges to face, everyone. It can be technical issue with your HPC solution, with your data center, your cooling. It can be problems with your application. It can be problems with a renewal. It can be how to access up-to-date technologies because your application needed to explore a new horizon. Or you can have all these issues at the same time. This is what we are trying to offer with Microsoft. Based on our experience, we propose to summarize the customer journey, the first 10 days spent working with us. Let me now go to the next slide. The day one will be a really important day. They are all important, but this one is really important because this is where we will meet for the first time, and this is where you will meet the HPC experts at Microsoft. I am one of them, hopefully. Inside this meeting, you will be able to express your current challenge, your current issue. You will be able to explain us your current solution and what you would like to do. We, as Microsoft, it will be the time to explain you what we can do as well. One of the examples can be the three well-known scenarios. The first one is the burst. The burst scenario is when you need to extend your current solution to Azure. So for this one, we have solution. We have connectors, and we are able to connect directly into your preferred scheduler. It can be LSF, it can be PBS Pro, it can be Slurm. And we have been able to work with all of them to be sure that this scenario is supported for you. Another scenario can be hybrid. You keep your on-premise solution, but for specific application, you don't want to use internal solution, but you prefer to use cloud directly. Like this, you can keep the cores internally for specific purpose. And then we do support as well the last scenario, which is a full cloud. You don't have anymore any resources on premise, and user can connect directly to the cloud solution as they can do right now on your solution. So typically, this is the discussion we have during this first day. Like this, you can understand how we can help you and how you can see your HPC in the future with Microsoft. If you decide to continue with us, this is where we start the second day. The second day is also really important. This is where we will start the design session with you. We will design and we will build with you our solution, your solution. By this, we will need to be in the same room. It can be virtual, it can be a physical room with a whiteboard where we will draw, where we will design your solution to be sure that this solution will fit to the need. We will have during that session to define what is a need, of course. At the end of this day, this is where we will really think about how now we can test it. And this is why we start the day 3. The day 3 will be the day where we set the frame. This is the day where we will define a scope. Of course, it won't be exactly the same solution as you have on premise, because the goal of a POC, a proof of concept, is not to do a full solution assessment. It's to check first some specific element. If it's burst, this is where we can check if burst is doable or not. If it's performances, this is where we can test the performances. What is really important during this kickoff POC, during this set the frame, let's say, meeting, is to define as well key performance indicators. This is where you will be able to say, okay, if we are able to check that box, if we are able to meet this criteria, it will be a success for me. And of course, what is important too is to define the budget, because you will need to maybe to mobilize some people, you will need maybe to deploy some infrastructure, and this has to be defined in advance. Like this, you will be able to check this criteria as well. Once this day 3 has been defined and the frame is now clear for everyone, the scope, sorry, we can start the day 4. So the day 4 is really interesting as well, because this is where we will run the POC, and then you will be able to check that what we have been able to design, what we have been able to discuss is as expected. So you will be able to check performances, you will be able to check the features according to the scope. So it's really important, this POC, and what is even more important that during this POC, we used to train your team, we used to train you to be able to deploy by yourself the solution and to manage it. Like this, you are able to learn at the same time. Once the POC has been done, this is the day 5 where we wrap up and we will check KPIs. You will share with us your lesson learned. We will share with you our lesson learned as well, and we will decide the next step. So it can be another POC or it can be a pilot. A pilot for us, it's really important because it is a place where we will try a pre-production system. This is where you will be able to implement all your solution with security, all the storage, with the data flow, all your process. And like this, you will be able to test a real solution as it can be on production in your solution on premise. So it can be identity, it can be a lot of things like this. So this is where we set the frame for the pilot. So day 7, this is where we will deploy the infrastructure accordingly to your requirement and has to be close as your system on production now. Okay? So this day 7 is critical because you will prepare the system for a key user. This is why you have the day 8 where you will open the system to key users and they will evaluate the solution. So we are trying to provide this as transparent as we can, but this is something really important, and this key user will be able to provide feedbacks as well. This is the day 9. The day 9 will be the wrap-up of the pilot. Again, this is a place where we will share lessons learned. This is where we will evaluate you will evaluate the solution, and the key user will say, yes, we have a better user experience. Yes, we have more feature. This is something we would like. Or if not a good pilot, we can redo a new one, maybe to add more content on it. But if the pilot has been as expected for you and you feel confident for the solution, this is where we start the day 10, where for you it will be the production part, where you will be able to run your HPC on Azure with a different mode, again, burst, hybrid, or full move to cloud. This is the end of this session, so I would like to thank you for listening, and I would like to hand over now to Gabriel Sala, and Gabriel will cover a specific industry scenario. Thanks a lot for your time, and I hope I will speak to you soon. Gabriel.
Good morning, good afternoon, good evening. My name is Gabriel Sala, part of the Azure HPC team here in Europe. And this session is looking at part 3 of the cloud HPC journey to Azure. I'd like to thank my colleagues Antigone and Alexandre, who showed you again a bit more, give you more insight in terms of how we as Microsoft are helping our customers into this cloud journey. In this talk today, I'm going to focus on primarily in terms of the area where I focus on is around automotive and manufacturing. How these automakers are using technology. So we know that, we've been running crash simulation for a number of years, the last few decades. But how does it look in the cloud? How does these automakers are leveraging on, again, the Azure cloud, but also on the existing investment on the on-prem data center? And I'm going to focus on, again, the key pillars that we see in this whole digital engineering platform. So what I mean by digital engineering platform, what are the components that will allow an engineer, for instance, to do what they traditionally do, but also extend it into the cloud? And what do engineers do in this space? They design, they use AutoCAD, they use various computer-aided design tools to design 2D and 3D wireframes. Once those are designed, how do they move it to, again, the next stage in terms of rendering? Once those are rendered, how are they going to model it? Once it's rendered and modeled, how do I simulate it? And also touch upon a little bit more about how AI is really impacting this space, and how within Azure and the cloud, AI has been really a key differentiator in terms of how quickly can I reduce the time to design, manufacture, and release this product in the field. On the next slide, I'm going to focus more in terms of what we've seen in the market. What are our partners? For example, PTC. PTC is a large organization that focuses on building this computer engineering software. And recently they've done a survey just to get a feel of what do these engineers think about, what's top of their mind. And typically, again, there's big focus on design, big focus on control, communication, and on collaboration as well. And you'll see on the next slide, again, those key environment coming to fruition. And the reason, again, they are pushed towards these different words in this page is basically where they are today in terms of how the new work, the hybrid work has impacted their day-to-day engineering activities. How does COVID change the way you design? How does COVID change the way you model an environment? Traditionally, you will see engineers, they will probably work to the office and they'll have under their desk a high-end workstation using the latest and the greatest graphics cards. Today, again, there's some restrictions due to COVID. How do they have, again, those tools at their fingertip to essentially do the same work? And in this case where I'm going to share a little bit more on the next page, what are these components that will allow them to build this digital engineering platform? And what do I mean by digital engineering platform? This is a platform that allows an engineer to have a single pane of control of these different activities: manufacturing, design, test, scale, model of a product, for instance. And you will see again in this page 4 key components: a cloud workstation, cloud rendering, simulation analysis, and deep learning. Let's start out on cloud workstation. Engineers are looking to have, again, a flexibility to work anywhere. And on top of that, now they're restricted in terms of their movement. Where do they need? Can they go and work in the office? But have they got the tool, the platform that allows them to look at the 2D model, share it with their colleagues, work on it in the same way that traditionally they'll work on a desktop? Using Azure HPC, the actual workstation is hosted on the cloud. The graphic intensive workstation is leveraging on our partners like NVIDIA and AMD to essentially give them the same look and feel that they traditionally have on a workstation running on their desk. And once you move that workload into the cloud, then you want to extend it in terms of leveraging what you already have in the cloud, in terms of storage, in terms of additional CPUs. Well, let's say you want to do some CPU rendering. So render multiple images to become either a movie or a high resolution image. But having that flexibility again in that same pane of glass has been critical to some of these engineers. They want to keep the data where it is. They don't want to be moving data from different locations. They want to share the data with their colleagues. They want to be really proactive in terms of how they collaborate on these same artifacts. Once the rendering is done, typically you render the image, then how do I move to the next step? I want to do a CFD simulation, or I want to make sure that, again, the design that I make, that I've created meets the guideline of a customer. How do you validate that product? And again, leveraging heavily on HPC, spinning up clusters to run a specific simulation. You can run a clash simulation, for instance. Recently, we've demonstrated, again, scale up to 80,000 cores on this simulation, running everything in the cloud using InfiniBand, using, again, leveraging heavily on the file and storage system that we have to be really efficient in terms of running this workload. So we've done a lot of simulation, we've done a lot of analysis, but are there any other services that will allow to really complement and enhance the product design? And recently, we've been, again, working very closely with partners in terms of how technology like deep learning, technology like image classification, object detection, allows essentially engineers to augment how they do these designs. So learning from previous design, allowing you to design the future products that previously would have taken months and years to go through a whole R&D to build those environments. And you can see at the top, again, we leverage heavily on areas like generative design, industrial IoT, and additive manufacturing, just to transpose those products. So always, as we look at this pane of glass, essentially what customers of us are looking for is trying to reduce the time it takes for them to design a product. So you design it much quicker, the product is released much quicker to the market. Very competitive market. How do I shorten the time it takes for a car maker to release a car on the market? So that's critical to this environment. And next is, again, a series of examples of, again, some of these specific use cases around design. Crash simulation, again, this has been, again, for decades, and one of the key areas where car makers, due to safety laws, due to compliance, have to run these tests across different parts of different safety standards. How do you do it effectively in the cloud? How do you spin up and spin down an environment that allows you to either leverage on your existing on-prem environment, but also extend it to the cloud, still keeping a level of, again, security, availability, and performance on that environment? Another environment is looking at multiple digital simulation. So how can I start with, again, a core product, but that product will allow me to create, again, different variants of simulation very quickly, very effectively. The cloud allows you to do that in terms of provide you an on-demand nature of the compute resources. So as I create my cluster, I want to now add additional simulation. I'll just spin up additional servers on demand, ready and available. Run your simulation. And finally, then also in terms of computer-aided digital manufacturing, this is very important, especially in markets where the car manufacturer or the manufacturer is looking at creating multiple variants of the same product. So I will start with a base product, but then I'll have 3 or 4 different variants based on geography location, based on country requirements, based on different standards. But I'm have that flexibility to very quickly build some mock-ups of products that will target a specific market or a specific customer requirement, but relying on the power of the cloud itself. So having, again, that on-demand native elasticity that says, I have a single product, but that product has 4 different variants. How do I design this environment? How do I design and test at scale this environment? Iterative design solution with multiple variables. So this is, again, really looking at the power of the cloud, but also of the underlying infrastructure. So I have GPUs, I've got CPUs, but again, I have this starting point of a single design, but how do I input new variables? How do I test these new variables at scale? The cloud allows you to do that. And also that flexibility that cloud allows you is, again, as new hardware is coming, new platform, what the key question is, again, how can I optimize my simulation? Not just in terms of performance, but also in terms of cost. And we've heard previously in terms of Antigone explaining, again, let's move away from that core price. Let's move more towards, again, that simulation price. I'm looking at end to end as I run this simulation. How much does it cost me to run those simulations, as opposed to what's the cost of a compute hour? And finally, I just want to leave you with these thoughts. We are here, we've got a team of really experienced HPC practitioners, and some of them have, just like me, started on-prem, learning how to build these HPC clusters, but recently spent more time in terms of how do we extend that to the cloud, and how do you bring the value of the cloud around elasticity, around on-demand nature, but also around having that ability to test, research, experiment in the cloud before going into a full-blown production environment. I'd like to thank you for listening to this talk, and hopefully we'll see you at supercomputing. Thank you.